Now we'll continue with the same example. So here is the example, given example. It's a ladder circuit. There are 6 capacitors. He's asking about find the total capacitance and voltage drop across each capacitor and charge on the each capacitor. So here first we found the total capacitance. As I mentioned, always if you haven't seen the first video, please watch the first video. Here I'm going to briefly explain what I did in the first video. So we always start from the capacitor, which is far away from the source. Find out if that capacitor is in series with something or parallel with something, and solve, minimize the capacitors in the circuit, and finally end up solving or finding the total capacitance. So that's what I did here. I found the total capacitance. Once I know the total capacitance, I know the total voltage, V total equal to 100 volts. So Q total, charge on each, total charge equal to C total times V total, which is 3 times 100, 300 microcoulombs. That's the total charge. Now, so the total charge supplied by the source is 300 microcoulombs. Now if you look at C1 and C10, so now you need to go back backwards from each circuit. Okay, so now I know the source is supplying 100 microcoulombs, so this one is supplying 100 microcoulombs of charge. So we know that in series charge is same. So from this I can tell Q total is same as Q1, same as Q10. Okay, so I can say Q1 equal to 300 microcoulombs. Q1 equal to 300 microcoulombs, and Q10 is also 300 microcoulombs. So I'm going to write it down here. So capacitance C, V, and Q. I will also find energy U or W or V. Okay, so C, I'm going to put C1 equal to, I know it's 12 microfarad. Now I haven't found the V1 yet. I will find V1, but I know Q1 equal to 300 microcoulombs. So based on this, can I say V equal to Q over C? So V1 equal to 300 divided by, what is C1? 12. So how much is that? Around 25 volt. So the voltage drop across C1 is, this is 25 volt. Let me see if I can use different color. So here it is 25 volt. That's a different color, I don't want to use that. And the voltage here, it must be 75 volt. Okay. So W equal to energy stored in the capacitor, which is half CV square, so which equal to C1 half times 12 micro times 25, so 25 times 6, which is 150 microjoule. That's energy stored in the capacitor 1. Now we'll move back to the second circuit from the bottom. Okay, so here when we look at the second circuit, I already know this voltage drop is 25 volt. Now the voltage drop here must be 75 volt. So can I say my C2 and C9 is same? So I have C2 equal to 1 microfarad, but I know V2 equal to 75 volt. Once I know V2, can I say Qt equal to 1 micro times 75, so it must be 75 microcoulombs, and work done or energy stored equal to half CV square, half times C times 75 square, So this is 1 micro. So that value is, let me use my calculator, that is 75 square divided by 2, which is 2812, or microjoules. That's micro. Two 2812.5 microjoule. Now C3, now I have C9, but I do not care about C9. All I care for C3. So if you look at here, I know the voltage across these two must be 75 volt. Okay, if you remember, in parallel charge division takes place, right? So what is the charge across C2? We just found charge across C2 is 75 microcoulombs. What is the total charge? 300 microcoulombs. So if I say so, I know this is 75 microcoulombs. So the rest of 225 microcoulombs is going to be across that C9. Now if you move back, so here I have 225 microcoulombs of charge. I have 225 microcoulombs of charge, because C3 and C8, they are in series. In series, the charge is going to be same. So the charge is going to be same. So I have C3 equal to, what is the C3 value? 6 microfarad. So I also know Q3. So C3 equal to 6 microfarad. I know Q3, which is 225 microcoulombs. Now I have Q3. I can say V3 equal to 225 divided by 6. 225 divided by 6, 37.5 volt. Okay, and from here you can excuse me. So from here we can find energy stored of C3 V3 square. I'm not going to find that to save some time. I'm already used up almost 7 minutes. I don't want to have any video more than 10 minutes, so I'm going to go a little bit faster. Now if you look at C4, now did we find the V3? We end up with 37.5. So the voltage here, so I'm going to go back. So this total voltage is 75 volts. Out of 75, this voltage is 37.5. So the rest of the voltage is going to be 37.5. So I can say C4 or V4. So you know C4, I know V4 equal to 37.5 volts. Okay, from there you can find Q4, you can find omega, or work done, or energy stored in there, in that capacitor. Now go back to the original circuit. Now I know this volt, I mean here it is 37.5 volt. Do we know the charge Q4? From here I can find Q4 equal to 37.5 times, what is C4? Is it 6? C4 equal to 4 micro. So 37.4 times 4 times 4. It's a 150 microcoulombs. So now that here is 150. So 225. So here this must be 150 microcoulombs of charge. The rest of the charge out of, 225 is going to be split here. So 75 microcoulombs is going to be there. Now if you go back here, I know this value is going to be 75 microcoulombs, this value is going to be 75 microcoulombs. This example looks a little bit exhausting because you're finding so many values in single example, but if you practice more and more, I mean, it's going to be a lot easier. Thank you.